going to talk about lesson 1.2, which is on squares and square roots. Before we begin today, I just want to remind you that if at any point I go too fast, remember that you can pause the video, slow down, go back, or re-watch any of the sections. So for today's lesson, in understanding the relationship between squares and square roots, the first thing we're going to do is back up a little bit and try and remind ourselves what a factor is. So to start, we have the definition of a factor is a number that divides exactly into another number. So an example would be 1, 2, 3, and 6 are all factors of 6. So we know that because 6 divided by 1 would equal 6. 6 divided by 2 would equal 3. 6 divided by 3 would equal 2. And 6 divided by 6 would equal 1. So 1, 2, 3, and 6 all are factors of the number 6. So the next question asks us to find out what the factors of 10 are. Well, we know that 1 will always work because if I go 10 divided by 1, we're going to get 10. Okay, so 1 works. The next one is 2. Well, I've got an even number, so 2 should work just fine. So if I go 10 divided by 2, well, that's going to give me 5. That works just fine. 3 will not work for this question. And I know that because if I try and go 10 divided by 3, it's going to leave me with the decimal. And that's the same with the number 4. However, the number 5 will work just fine. And I know that because when I divided by 2, it equaled 5, which means if I go 10 divided by 5, it's going to equal 2. And 6, 7, and 8, and 9 all will not work. They will leave me with decimals. But if I use the number 10 itself, that will work. So it's important to remember that 1 and the number itself will always be factors. Okay, so 10 divided by 10 equals 1. So we know the factors of 10 would be 1, 2, 5, and 10. All right, for our investigate question today, we will do today's investigate question. We have this massive chart that shows us some of the factors filled in for the numbers 1 to 16. Okay, we're going to try and finish the chart because 1 to 8 have been done for us. So we're going to try and see if we can fill in this chart for the numbers 9 to 16. So let's see if we can finish this off. So for the number 9, like I said already, we know that 1 and the number itself will be factors, but let's see if we can find any more. So I start with 1. 2 is not going to work because we've got an odd number. 3 will work because I know I can put 3 into 9 times, 3 times. So 1, 3, 4 doesn't work because I can't go 4, 8, then the next one is 12, so it's not going to happen. 5 doesn't work, 6 doesn't work, 7 doesn't work, 8 doesn't work, but the number 9 itself will work. The next one is 10, which we just did in our example above, so I know that it's 1, 2, 5, and 10. Next we have 11. Well, 1 will work, 1 will always work, so we can fill that in maybe for the rest of them. 11, this one gets kind of tricky because we can't do 2, we can't do 3, we can't do 4, we can't do 5, 6, 7, 8, 9, or 10. And you can check those on your calculator if you want. If you try and use any of those numbers and go 11 divided by 2, 3, 4, 5, 6, 7, 8, 9, or 10, it's going to leave you with a decimal each time. So the only factors of 11 are 1 and 11 itself. Well, the next one is 12. This one has a ton of factors. So we have the number 1 itself. 2 will work because 12 divided by 2 would give me 6. 3 would work because 12 divided by 3 would give me 4. 4 would work because 12 divided by 4 would give me 3. 6 would work next because 12 divided by 6 would give me 2. And the number 12 itself would also work. Any numbers in between there, feel free to check with your calculator or some long division. They're going to leave you with decimals or remainders. 13 is another simple one. The only numbers that work for 13 as factors are 1 and 13 itself. 14 gets a handful. 2 would work for 14. We would also have 7 that would work for 14 because 14 divided by 7 would give us 2, a nice whole number. So we're going to say 7 works and 14 itself. Okay, 15, we have a few that work here. 1 itself, 1 always works. We also have the number 3. 15 divided by 3 would give me 5, which means 5 is also going to work because 15 divided by 5 gives me 3, and we have 15 itself will work. And 16 gives us a handful here as well. So we would have the number 1. It's an even number, so 2 is going to work. 16 divided by 2 gives me 8. We would also have the number 4 work for us because 4 times 4 is 16, or 16 divided by 4 equals 4. 8 would work because 16 divided by 8 gives me that 2, and 16 itself is going to work for us. So now that we've got our chart completed, we're going to fill down or scroll down, and we're going to try and answer a couple of these questions. So the first one says, which numbers have only 2 factors? Well, if we look at our chart above, which numbers have only 2 factors? Well, those are all the numbers that only were divisible by 1 and itself, and that's numbers like 2. We also have the numbers 3, 5, 7, 11, and 13. Okay? Well, the next question says, what do you notice about these numbers? Well, what I noticed about these numbers is all of these numbers become prime numbers. And if we remember from the past, prime numbers just means they're only divisible by 1 and themselves. The next question asks us which numbers have an even number of factors, but more than 2. Okay, so an even number of factors, but more than 2. Well, that's kind of tricky, but let's take a look. Okay, so if I scroll down my list, an even number, but more than 2, well, that's not going to be 2. That's an even number, but it has to be more. So the next one would be 4. And if I look at my chart, the first one I hit is the number 6. Okay, the next number would be 8. If I keep scrolling over, the next number is 10. Okay, and if I keep moving over, well, we've got the number 12. It has, let's count, 1, 2, 3, 4, 5, 6 factors. So that is an even number, and it is more than 12. 13 only has 2. Then we have 14. That one has 4 factors. And if we look, we have 15 as well, which also has 4 factors. Okay? So those are numbers that have an even number of factors, but more than 2. The next question says, which numbers have an odd number of factors, and what do we notice about them? Okay, so let's look at which ones have an odd number. So that would be like our first odd number here. Well, they all have at least 1. And the first one, the number 1, only has 1 factor. It's 1 itself, okay? The next one would be 3. Anyone that has 3 factors, well, the next one I see here is 4. So we would have the number 4. We also have the number 9 that has an odd number. It only has 3. And then if I keep scrolling over, well, I don't have any more that just have 3 factors, but I have one that has 5 factors, and that's 16. And what did I notice about these numbers? Well, all of these numbers end up as perfect squares. They would all be perfect squares. And I know this because I can check with one of my area models from last lesson. So I'm going to use the number 9. So is the number 9 a perfect square? Well, let's see. If I draw a square that has an interior area of 9, can I make it work to have a whole number as a side length? Well, if I cut this into sections of 3 and 3, I get an area on the inside of 3, 6, 9, and a nice even number on the outside that's the same. So 3 times 3 equals 9, which means 9 is a perfect square. All right. Now that we have an understanding of how factors can relate to perfect squares, we're going to scroll down and take a look at the connect here. Okay, so it says ways to tell whether or not a number is a square number. So A says we can find a division sentence so that the quotient, or the answer, is equal to the divisor, the number you are dividing the bigger number by. So in our example, we see that 16 divided by 4 equals 4. Well, we know that this is going to be a perfect square, 16, because since it's being divided by 4 and it equals 4, that's going to tell me that it could be a perfect square, because if I had a square that had side lengths of 4, that would give me an interior area of 16. Okay? We can also use factoring. So factors of a number occur in pairs. These are the dimensions of a rectangle. Again, we're using the number 16, and we can see that for by 4 gives us an area of 16. So we're just going to scroll down a little bit and fill in a few more notes. It says, since 16 has 5 factors, which are 1, 2, 4, 8, and 16. Okay? Since they're an odd number of factors, one rectangle is a square, the square has side lengths of 4 units, we say 4 is the square root of 16. So we would write 4 is equal to the square root of 16, just like so. When a number has an odd number of factors, it is a perfect square. So it's a perfect square. Okay? When we multiply a number by itself, we are squaring a number. Squaring and taking the square root are opposite or inverse. So opposite, or we can also say inverse operation. So that's the same as like adding and subtracting or multiplying and dividing. They simply undo each other. So for example, 4 times 4 equals 16, which means 4 squared is 16, while the square root of 16 equals 4. So they are opposite operations. We could also look over here and we could say the square root of 4 squared would simply equal 4. I know this because since I have the original number 4 and there's 2 operations happening to it, we are square rooting it and we are squaring it, these essentially cancel each other out, okay? So they are totally opposite operations.